Assalamualaikum. My name is Fazil Azim bin Rupahya and my group members are Satish Gominadan and Muhammad Hazim bin Hamid. Today my group choose the Switch Lab EV for our presentation. Today I want to present about safety before and during any activities. What is safety? Safety is a concept that includes all measures and practices taken to preserve individuals' life, health, and integrity. In the workplace, safety is measured through a series of metrics that track the rate of near misses, injuries, illness, and fatalities. For the working area, it must be flat area, dry areas without any liquid, and the car being serviced must be at least 3 meters away from other vehicles, and it is must in a room temperature area, and after that is a good ventilation. It is because it to ensure no explosion before and during any activities. For personal protective equipment, we must wear insulated glove, safety boot, goggle, and safety jacket. It is make sure no injuries for ourselves. And lastly is insulated tools. The tools are fully insulated and can be provide protection up to 1000 volts, and it have a mix of orange and yellow and a label that use symbol of the straight triangles and 1000 volts printed on the tools. And you can see this is insulated plier that it can provide protection up to 1000 volts, and after that the insulated tools like screwdriver, ratchet, and the bolt. That's all for me. Thank you.
My name is Muhammad Hazim. Now I will explain about motor and battery specification. Okay, for the Switch EV, it uses the DC motor. The function of this DC motor is to convert electrical energy into mechanical energy, and then this DC motor applied to large mechanism that power from vehicles. And then the type of DC motor that Switch EV use is series DC motor. It is field windings are connected in a series, and then the series DC motor are creating much faster speeds, and it cannot regulate their speed particularly well. Okay, this is the picture of the motor of Switch EV. The model of this motor is ES156. It DC series motor, and then the voltage of this motor is 48 to 72 voltage, and then 9 horsepower or 72 continuous rate. The torque peak of this motor is 88 Newton meter and 30 horsepower peak with 450 amp controller. And then the weight of this motor is 62 pounds or around 28.1 kilogram. Okay, this is the picture of the DC motor place. Okay, as you can see at the left side, the motor at the center or front of the tire, And the right side, as you can see, this is the switch EV vehicles. The place of the motor at the behind, as you can see. Okay, now I will continue to explain about battery for switch EV. The model of this battery is CB1285, and the type of this battery is seal lead acid. The cells per battery is 6 cells. The voltage of this battery 12 volts. About the capacity, it 85 amp hour or 20 hour rate to 1.7 per cell. For max discharge current is 800 amps in 5 seconds. For internal resistance is 5.5 milliohm. The recommended max charging current is 24 amp, and then this battery is using the type of terminal is F11, and then the weight of the battery is 54.67 pounds, around 24.8 kilogram. Okay, this is the picture of the battery for switch EV. At the left side, as you can see, the battery at the front of the switch EV, and the right side is the switch EV vehicles, the battery at the in front of switch EV, and then the battery must be covered.
Okay. My name is Satish Gopinathan and I'll be presenting on the Switch Lab EV electrical system. This is an electrical diagram for the Switch Lab EV. Here we have a four main component, which is the or main four main system, which is instrument panel and auxiliary system, motor control system, and also battery management system BMS. Okay, let's look in detail what are the components in the battery management system. We have a charging port, battery charger, battery pack controller, and also battery pack. Each battery contains 12 volt current, and overall they all are 72 voltage. And then in a motor control system, we have a main contactor, motor controller, forward reverse controller, DC-DC converter, 12 volt auxiliary battery, a junction block, and another system is an instrument panel and auxiliary system, and motor, which is propel the vehicle. Let's see how this electrical system function. This electrical system or the battery pack receive charge or need to be charged using the external current, where the current will be passed through the charging port. The AC current will pass through the battery charger, which is converted to the DC current and pass by the battery pack contactor before it's reached the battery pack to charge. And then the charge current will flow through main contactor before it's flow through the motor control system. Here, so the supply current go to the motor controller, and the current will supply to the forward reverse controller to make sure or to control the motor during forward motion and the reverse motion. Here we have a 12 volt auxiliary battery, also DC-DC converter. Here the DC-DC converter receives current from the high voltage battery, and the auxiliary system in the EV switch lab EV vehicle still using 12 volt current, and the 12 volt current will be supplied by the 12 volt auxiliary battery. When the 12 volt auxiliary battery lose charge or the voltage is low, the DC-DC converter receives current from the high voltage battery and step down the current and supply to the 12 volt battery to recharge it back. Okay, let's see how the system function in a drive motion. When the current is already in the battery pack, the current flow through here, and the, the current will supply to the motor controller. During the forward motion, the forward or reverse controller will supply according to the required motion to the motor, whether the motor need to be proper in forward motion or in a reverse motion. In an auxiliary system, we have a signal indicator, high and low beam light, brake light, and also other sensor which is still function in a 12-volt current. Next, let's really see how we're going to troubleshoot the fault in a switch lab EV vehicle. This is a diagnosis flowchart. The tools that we needed to conduct the troubleshooting process is multimeter in a category of 3, which is suitable for high voltage current with maximum of 1000 volt, and also a battery tester to test the 12-volt auxiliary battery. Let's see what is our problem. The problem is the EV auxiliary system is not functioning and vehicle cannot start. When we identify the problem, let's look into what we should identify also the possible cause for the problem. Here we have 4 possible causes, which is faulty HV battery, faulty auxiliary battery, DC-DC converter malfunction, and also faulty contactors. Let's see the first and foremost possible causes. And we have a question here. Is that HV battery is insufficient? Which, let's say, this problem can occur even when the high voltage battery is no power. So here, when we ask this kind of question, is the high voltage battery is insufficient, then what we should do? Recharge the high voltage battery. Okay, once the battery is recharged, then it shouldn't be a problem. Then let's look into the second possible causes, which is faulty auxiliary battery. Here we have to ask a question: is the battery voltage is below 12 volt? Okay, we should know that the 12 volt system will function from the 12 volt auxiliary system. So when the current is low from 12 volt, the system will be not energized. So when the 12 volt auxiliary battery is low powered, then we should recharge the battery or replace if needed. Okay, we should check this battery using battery tester. Okay, followed with the third possible cause. Okay, the third possible cause is DC-DC converter malfunction. Okay, here is the detailed process how to we check the DC-DC converter. First question that we should ask is the output voltage being 0 volt, where the current flow out from the DC voltage is 0 volt? If yes, check the input voltage, where when the current is output voltage from the DC converter should be 12 volt. So when there is no current, then we should check the input current, which is from the high voltage battery. If the input current is also 0 volt, then we come to know that the DC converter is not receiving any supply current from the high voltage battery. Then check the continuity. Another possible cause also is the current cannot flow when the circuit is open, or there is a possible cause of open circuit. Then we check the wire for the continuity test we using multimeter. If the wire is broken or the open circuit, then we replace the wire. And then we go for the fourth possible causes, which is faulty contactor. Then we ask a question here: is there no continuity between the contactor poles? Okay, a good contactor should have continuity between the contactor poles. If yes, if there is no continuity between poles, then we should replace the contactor. Let's say if the contactors have the continuity, then we should also check the resistance. Then we ask a question here: is there no resistance between the contactor coils? If there is no resistance, then we also need to replace the contactor. If yes, then the contactor is, shouldn't be the problem. So if all these four possible causes are encountered or in a normal condition, the EV auxiliary system will function well and the vehicle able to start. That's all for me. Thank you.